Hi everyone, today we're going to continue on the lesson of 5.2, composition of two functions, and that's part of the inverse functions. So we're going to learn what is a composition function and then perform some operations that involve inverse functions dealing with composition functions. And so here we go. And let's go ahead and take a look at the definition of what is a composition of two functions. So basically, a composition is a function within the function. So for example, we read this as f of g of x, which means inside g of f of x, we're going to let x be g of x, which is another function. So just simply put, it is a function of a function. So just using f of x and g of x alone, we can make four composition functions. So the first one is f of g of x. That is the function of f evaluated at g of x. Well, we can also do the opposite, which is g of f of x, which means we are evaluating g of x at f of x. We can also do f of x, which means the function is evaluated at itself, and also g of x. So we have four different types of compositions that can be formed just using the two functions alone. So now we're going to take a look at how a composition function actually works using some specific examples. So let's take a look at the first one. So given that f of x is equal to x plus 1 and g of x is equal to 2 minus x squared, we're going to find the first composition, which is f of g of x. So as I mentioned earlier, a composition function is evaluating one function at another function, which means basically we're going to evaluate the function f of x and input g of x into the x value. So wherever you see x, we're going to actually put in g of x. Basically, that's what it means, right? So we're going to enter f of g of x. Well, we know that f of x is equal to x plus 1, right? So next thing, I am going to actually just identify the function x. So I'm going to actually rewrite this using parentheses to represent x. So x is parentheses plus 1. So basically you can read this as x plus 1, which is what f of x equals to, correct? And so next, what we're going to do is, as we notice that we're going to enter g of x inside and substitute it in terms of x. So wherever you see x, and that is why I left the parentheses here, we're going to enter g of x. So g of x is going to go in here. And g of x is actually equal to 2 minus x squared. So we're going to enter 2 minus x squared. So this is f of g of x. We have just substituted g of x into the x for the f of x function. Next, we're just going to simplify and combine the like terms. So we are going to just remove the parentheses. So we'll just have 2 minus x squared plus 1. And then combining the like terms, we will have negative x squared. 2 plus 1 is 3. And we're just going to write it and leave it in standard form. And basically, this is the function f of x evaluated at g of x. Okay, next, we're going to do the same thing, except this time we're going to enter f of x inside for g of x. So we're going to start with g of x as the big picture. So here is g of x, which is 2 minus x squared. Again, we're going to replace the x with parentheses. And what are we going to put inside the parentheses? Well, we're going to enter f of x. So f of x goes in here. And what is f of x equal to? That is x plus 1. So we evaluated f of x into g of x. And that's what we did. So next thing, again, we're going to have to simplify this. And notice there's a square there. So we're going to need to tap back into the Algebra 1 knowledge that you have. We're going to FOIL this. So we're going to FOIL x plus 1 squared on the side. So x plus 1 squared, that's going to be FOILing first term, x squared, plus x, that's plus 2x in the middle, and then plus 1. So we know that this is going to give me x squared plus 2x plus 1. Next, we need to simplify this by taking out the parentheses, but notice there is a negative in front of the parentheses. So we're going to distribute the negative through every term, that's going to make every term the sign change. So we're going to have negative x squared minus 2x minus 1. And again, leaving it in standard form, that's going to give me g of f of x is equal to negative x squared minus 2x has no like term, and then 2 minus 1 is just a plus 1. And that is the final answer for evaluating g of x at f of x. And let's try some more examples. Next, if you can just pause this video and go ahead and try the two that are given before you look at the answers, that will be a great idea. Hopefully you've had a chance to try it. So now let's go ahead and evaluate the function f of x again at g of x. So we're going to start with f of x, which is x squared plus 1. And we're going to enter g of x inside. So g of x is equal to 2x plus 2. And now we're ready to evaluate and simplify this expression. And so we have 2x plus 2 squared. We're just going to have to FOIL that again. 2x plus 2 square means there's two of them. 2x plus 2 again. FOILing means we have first term, which is 4x squared. Then we have a plus 4x and another plus 4x. That's going to be a plus 8x. And then finally, last term gives us plus 4. And then there's a plus 1 at the end. We're going to bring it down. So we're going to simplify, and looks like it's already mostly in standard form. So we got 4x squared plus 8x, and the last two numbers combine into 5, and that is what f of g of x gives us. And that is the final answer. Next, we're going to try g of f of x, going backwards. So g of x is equal to 2 times x plus 2. And again, I'm letting x be parentheses right here. So think of that as a parenthesis. And then what am I going to put inside? And that's going to be f of x goes inside the parentheses. So what is f of x equal to? It is equal to x squared plus 1. This one, I'm going to just distribute the 2 through. So we got 2x squared plus 2 again. And we got 2x squared plus 4. And that is what g of f of x equals to. So we've had a couple of examples dealing with composition functions. And next, we're going to give you a chance to try some more on your own. So here's two more problems. Make sure you pause the video and try the problems before you move on. And here is how we do that again. So f of x, again, is equal to 2. And we're going to let x be parentheses. So 2x squared, that's what f of x. And inside the parentheses, what are we going to put? That's g of x, right? So we're going to enter g of x, which is 4x plus 2. Again, using order of operation, we're going to need to square that first. So we got 4x plus 2 times 4x plus 2 again. That's going to give us 16x squared. Plus 8, that's going to be plus 16x. And then last term is plus 4. So that takes care of the square. And now we got 2 in front. So we're going to distribute 2 through every single term. So we got 32x squared plus 32x plus 8 as the final answer for f of g of x. And there it is. Next, we have g of f of x. We're going to enter again by substituting parentheses for the x. And we're going to substitute f of x equals 2x squared inside. And now this one, we're going to just distribute, actually just multiply 4 times 2x, which is 8x squared, plus 2. And that looks like is our final answer. So g of f of x is equal to 8x squared plus 2. So check your answers to see if you're getting them correct. If you are, then you are ready to move on. If not, then you just need to go back and review and make sure that you're getting this. Next, we're going to take a look at the idea of how the composition functions are related and how we can find the inverse of two functions. You can compose a function and its inverse. For instance, the mapping diagram shows that f inverse of f of x, where f of x is the original function and f inverse of x is the inverse. Notice that the range of f of x serves as a domain. Remember, interchanging x and y gives you the inverse. So let me just labeling. think of this as two separate functions. We got f of x. Instead of calling this one g of x, we just call it f inverse of x. So they are two separate functions. So the original domain, we can label it as x, and the domain, the range is y. But with the inverse function, if you switch x and y, then y becomes x in the inverse function, and then the original x becomes y. So that means so if we want to actually just rewrite this to make it less confusing, so now we got four sets of numbers. We got x, y, x, y. But interchanging the y and x, now x becomes y and y becomes x. Now the x is going to become the y. So we got -4, 0, 1, and 4 is now the y value for the inverse. It was the x value, but now it's going to be the y value. So part B asked, what do you notice about the outputs of the f inverse of f of x? So what you should have noticed is that the inverse, so instead of calling this value y, I'm going to reverse it and call it f inverse of f of x, because that's basically what it is. And notice that these values become the actual original x values. So basically, we're saying that the inverse of the function is going to give you back the x values, the original input. So notice those are the same numbers. So that is the difference between a function and the inverse. So when you switch x and y, and that's how you get it. So why does this make sense? Because when you take the composition function and you take the input and you assign it to the output, and then to get the inverse, you switch it back. And now you're back to the original x value because you switch the x and y. So that's why this actually makes sense. So you get the original x values back. So here is two equations that leads you back into the original. So if you take a look at the previous chart again, the f inverse of f of x, which means this last column, is actually equal to x. And so the f of inverse is actually the original as well. So that's how the two inverse functions are related. The graph of the functions and its inverse always reflect across the line y equals x. So in the previous lesson, we had you guys draw the dots and remember how this is the mirror, and whatever points you see here, they were reflected. Okay, do you guys remember that? So that is the idea of the inverse, how they're related. So if you have something that is a parabola this way, and you will have it reflected this way, so you will get something like this reflected. So that's what the picture looks like when you have the inverse of the function. They're reflected exactly across this line y equals x, and we're going to take a further look into it and see how the graph are related. So that's going to come up next. Well, but for right now, we're just going to be working with the algebra to show that two functions are actually indeed inverses of each other. So here are two functions. Here's an example to show. So we're going to use composition to determine whether the pair of functions are inverses. So whenever you see the word composition, you need to start thinking, well, I'm going to be actually using things like f of g of x. That's a function within a function. So that's what composition means, okay? So basically, they want you to show that f of g of x is equal to x, and g of f of x is equal to x as well. Remember previously, we have the two equations right here that if you can show that the two functions undo each other, you get back to x, then that's how you have two inverse functions. So basically, they want you to verify that these two, so we don't know if they are, but we're going to verify. It looks like it might be, but we still need to verify. So this is how we're going to show that the two functions are actually indeed inverses of each other. So we're going to perform the composition functions just like we did earlier. So we're going to start with f of g of x. So evaluating f of x at g of x, right? So remember that we're going to just let x be parentheses. So we're going to have 3 times parentheses plus 2. So that's 3x plus 2. And what are we going to put inside the parentheses? We're going to put g of x in here, right? So g of x is actually x minus 2 over 3. And again, we're going to use our order of operation and just do some simplifying here. So notice the 3 and the 3 will cancel out, and we have x minus 2 plus 2. And magically, the 2 and the minus 2 will cancel out. That'll leave you x by itself. So now we have shown that f of g of x is equal to x. That's only halfway through. So we're only going to be, it's like going from home to Rosemead High School, and now you're halfway there. But you need to be able to verify that this is a good route. So you need to be able to get back from Rosemead home to show that this is a good way to, commute, to travel, right? So we also need to prove that g of f of x is equal to x. So we're going to start with g of x this time. So g of x is x minus 2 over 3. And so what are we going to put inside the parentheses? We're going to put f of x, right? So f of x is 3x plus 2. And this time we're just going to simplify the top of the fraction first. So notice that 3x plus 2 minus 2, the 2's will cancel out. And we got 3x over 3. And the 3's will cancel out, leaving us x by itself. So we have g of x, f of x equals x. So we have shown both ways, back and forth, that they both equal to x. So yes, we can conclude that these two functions right here, f of x and g of x, are inverses of each other. So that is how we verify if two functions are inverses of each other. And hopefully that makes sense to you. So we're going to try more example. So next we are given these two right here. And again, you're asked to verify to see whether their functions are inverses of each other. So you can go ahead and pause the video and just try the problem before you actually check. Hopefully you've had a chance to try it. We're going to actually verify f of g of x. And again, we're going to start with f of x, which is 3x plus 4. And what are we going to put inside the parentheses? We're going to put g of x in there, right? So g of x is equal to x plus 4 over 3. Again, we're going to simplify. The 3 and the 3 cancels out. We have x plus 4 plus 4. And the 4's do not cancel out. So we got actually x plus 8. So we did not get x back. What does that mean? That means we already can conclude that we didn't even make it to Rosemead High School. So this route is no good, right? It's a dead end. So we can say right away that no, these two are not inverses of each other. We didn't even pass one way. But the only thing is we need to make sure that you double check that you did not make any mistake in the process to make this conclusion. So that's why details are very important here. So you need to make sure that you do not make a mistake. And now I have a few problems for you to actually try. So go ahead and try these problems to see if you know how to perform the operations to verify whether they're inverses of each other. So go ahead and pause the video and make sure you try all these 3 problems before you see the answers, okay? And here we go. We're going to verify f of g of x is equal to x plus 4. What are we going to put inside? We're going to put g of x inside, right? So g of x is x minus 4. And so we got x minus 4 plus 4. The 4's cancel out, and we got x. So we're halfway through. We're going to go f of g of x, and we're going to start with g of x. That's x minus 4. And what are we going to put inside? F of x, right? So that's x plus 4. And notice that the 4's will cancel out with each other. So we have both of them give you x back. So now we have verified that, yes, they are in fact inverses of each other. Let's try the next one. F of g of x is equal to 2x plus 2. What are we putting inside? G of x, right? So we got x minus 2 over 2. The 2's will cancel out. We got x minus 2 plus 2. That gives us x back. And we're going to go g of f of x is equal to, we're going to start with g of x. That's x minus 2 over 2. And what are we putting inside the parentheses? We're putting f of x, right? So f of x is 2x plus 2. We're going to simplify. The 2's will cancel out. We got 2x over 2, which gives us x back. So in fact, The second one is also, yes, second pair is also inverse of each other. And then the last one is that f of g of x equals 3 times x, and x equals x over 3. The 3's will cancel out. You get x right away. And g of f of x is equal to x over 3. And what are we putting inside? F of x, right? F of x is 3x. And the 3's will cancel out. And again, you get x back. So in fact, all three of them are inverses of each other. And so that is how you verify. So hopefully you've had a chance to practice verifying two inverse functions using composition function. And so today you're going to have homework, and go ahead and follow Google Classroom and make sure that you do the homework assigned for today. And have a great day.